Welcome to the DS Incubator. This is the series about working with a terminal. Today we're going to be talking about finding things with grep and with find. The objectives are motivated by three use cases. One is to find interesting arguments in a health file. Another one is to move our RStudio projects from wherever they are in our computer, maybe excluding trash, to a folder where we can keep them all organized. And third, we're going to be pruning our trash. Today, the lesson is in folder number 3, and I am going to be using this computer environment. You don't have to, but if you do, then you're going to get the exact environment and also some of the data that I'm going to be using here. Click, here we are. Let me clear with Control L, and let me do a CD, a change directory to my home. Where is this? Bring working directory. This is home RStudio. What do we have here? We have a few folders. Let me show you that RS has nothing, and then the other folders, we're gonna learn about them in a moment. So I'm being guided by this lesson here, so let's put it here to the right. Maybe make this a little smaller. My computer environment, I don't need that anymore. As small as it gets. There we go. Or not as small, like a little bigger here should be fine. Okay, so here the first thing I would like to do is to talk a little bit about grep. Grep is this amazing command that helps us find things. So the help file is long, right? So let's clear this up, just to have a hint, a gist of what it does. We can have a look at the head of it, and this already shows at least the usage, which is like usually how you can get started. So grep takes some options, like for example -I is an option that I'm going to be talking about today, which makes the matches for the pattern insensitive to case. So if you use the -I flag, then you get upper cases and lower cases indistinctively. So then it takes a pattern or many patterns. So a pattern could be something like I comma. As you can see, that every flag is has a letter and then a comma. So let's try to learn about that particular flag. So that's gonna be my pattern, or it could be F, if you will. Actually, F I think is gonna be a bit more useful for this case. So with that, if I run that, well, actually, I get nothing because it's waiting for the file from which the text comes. But I'm not gonna be passing any file. Instead, I'm gonna be actually passing the output of grep help. I'm gonna pipe that into grep itself to then search through the help file and find that pattern F comma insensitive to case. So if I run that, here you can see how it matched capital F and lowercase f. So that's how the general use of it. It has, of course, a lot of options that you can play with. One really cool one, I think, is that you can create a file with the patterns that you want to match. So for example, if I want to match, well, as I said before, maybe the pattern F comma, but also I comma, and also V comma, and also N comma. So let's see, those are some of my favorite arguments. What did I do here? Let's try to escape, column, save and quit. Press enter to continue. Save, column, save and quit. Yeah, no. Invalid command lines, it executes. Enter to continue. Patterns. Okay, column, save and quit. Finally, good. So if I do a cut for patterns, you can see those are the patterns that I have. So I'm going to use that again. Remember the grep. My call to grep looked something like this, but now I'm going to modify it because now I'm going to be using a file, and the file is called patterns. So that's what I'm going to do. So here it is. The matches, let me clear this up, call this again. The matches show me that grep not only matches one occurrence of the thing, like here, for example, there's nowhere else in the help file of grep that has the sequence, lowercase v, comma, but it matches all the occurrences. Like in this case, like n comma appears here too, right? So it matched the two occurrences of it. It could be any number of them. So that's how you use grep, and that's how we learned, for example, that the -f, which is the flag that we use here, is the one that you need when you have a file that contains the patterns, right? Takes a pattern from file. The -i is the one I already told you about, the one that ignores the case, and then v is cool because it helps you invert the pattern. So you can sometimes it's easy to express what you do not want too much. So you pass the pattern with the -v, and you get everything else. And then n is really cool because it allows you to show the line numbers, not capital N, just lowercase n, the line numbers where the files occur in the file. The matches occur in the file, right? So if you want to then look for line 12 in your help file of grep, then you can pass it to cat n to get the line numbers, and then in line 12, you have that match that you are looking for. Okay, that's about grep. You can use it in many cases, so it's useful to know about it. Next use case is to learn how to move RStudio projects. So RStudio projects are cool in that they are flagged by one specific file that ends with .rproject. So we're gonna find those files. So find is a command. If you type find and enter, what you will do is we're gonna match every single file that exists under the default directory, which is the root, this one here. But it's more interesting if you do something more specific, like for example, find all the files that are in my home, and by default it has an action that is the action to print things to the console, like here. But there's other actions, like for example ls. So once you've matched those files, do something other than printing them. Give me information about those files, and here's what you get. Right, and there's many more actions. Some are very useful, and we're going to be talking about them today. So find here in my home, and now we're going to be using what's called tests. So we know that we have an action print, we have a path that is home, and then in between you may have tests. What are tests? Well, something like, okay, the name, I want it to be whatever that has that ends with rproj, for example. So then I'm going to remove the print because it's implicit. This is what we get. We discover here in my home all the projects that we have. Interestingly, I don't want to match this one here because it's in my trash. I'm about to move only useful RStudio projects to a directory called rs. This one here. RS right now has nothing, but in a moment it will have what I want to move there. So it will be interesting to match not something that in the path, this is part of the path, not just the name, which is this, but the path is the whole thing. And I want that the path not to match anything, then the word trash, and then anything. So if I do that, then I only get these two directories that are the ones that I want to move. So now we are gonna get creative. So to move these things, I want to move the entire the folder, not just the file rproj. I want to move the parent of that file, the folder abc in this case, or the folder xyz in this case, right? So how do we do that? Okay, the command dir name, if you give it ab, it will give you a. So that is, or if you give it abc, it will give you ab. So excludes the file name component of a path. basically that's what it is. So that's what we're going to be using here. So once that we have the files that we want to pass it to dir name, but this will so everything that goes to the left would be passed here to the right, implicitly, but this will fail. Why? Because dir name needs not the paths as we get them from here, like one line, it wants them one next to the other. So if I do xargs, this is the other magic find utility to find things, and I do an echo, you can see how those files are now in the same line, separated by space, as opposed to separated by a new line. So xargs creates one command line for each of the things here, basically. So what we want is to pass, after we pipe it, we call xargs, and then we pretend that everything is fine. Dir name, and here we would have the directories that we want to get the dir name for, but we won't write them because they're going to be piped from the left. Anything that comes all the way from the left goes all the way to the right. So here they are. Those are the directories that we want to move. And now is where things get interesting. Again, we need to do xargs because we're about to move files, but all these files. We don't have just one. We need to move all of them at once, and move takes files and a destination. But you can invert this. You can do destination and files if we use the flag -t. So that's what we're going to do. So the destination is going to be the directory rs, and the files are going to be piped all the way from the left. So this one here, I'm going to leave it empty because it's going to come from the left. So I run that, dir name terminated by single 3. What's going on here? This xargs made a mistake. Xargs. This is what I wanted to type. So now if I do this, if I find my RStudio project except for trash, I can see that they are all here neatly organized in RS. So I could do an ls for an ls recursive inside RS, and you can see how they are all here. My XYZ that contains the R project, and ABC that contains the R project. Everything is in there. So the directories are here, and then they spell them out. Do I have the command tree here? Which I doubt I could. No. All right. With that, we've learned how to find things and how to move directories, how to use xargs. Now it would be nice to remove the things that we have in trash. So we're going to be finding things not in the home, but specifically in trash. So from all of this, I want to exclude the name of the folder itself. So I don't want the path to contain the word trash. So with this, I get just the contents, not the folder itself. And now is when we can use another action. Remember that we have the action say ls and the action print. Well, we also have a very useful action. Guess what? It's called delete. When you do that, you remove the content. So if I do a find on trash, I have now nothing. What I had there is gone. That is, of course, dangerous. So you have to be careful because in this case, you have no confirmation. Let's create some stuff in there to show how other things you can do, what other ways you can delete files and directories. So another way is similar to what you already. So what I just done is to create some content. So if I do a find on trash, I can see that there is something there. So I'm about to do something similar to what we did before. So find. So find, but we're not going to use delete. Remember that we now know how to use xargs, so we could pass xargs to remove, right? So remove takes here the files that will be coming from the left hand side of the pipe. So this should work, except that we'll need recursive because we are deleting not only files but also directories. This is something that we already talked about in previous meetups. And if we want even the directory names to be removed with no messages, you can say F for force. So that will make sure that now your trash is empty, but the folder itself is there, right? We could also remove, as usual, interactively the file patterns because we don't need it anymore. Yes, remove it. And what else? Okay, what's the safe way then to remove things? Let's copy this back again and paste it here. So what I'm doing here is to create some content for trash, so I can remove it. So another way would be to find in trash something that is not the path, not the name trash itself. So that will give me so the name of the directory A and its content. And now we can do another action that is called exec. So we learn about ls, we learn about print, we learn about what else we learn about delete, and now we're going to learn about exec. Exec is more general than Xarx, for example, and it's very general, so it can execute any code, including remove. And now, instead of relying on things being passed to the right, we can choose where we pass, where we inject the arguments that come from find. So find, prints, these things. So we're gonna insert them in here, right? So we can also say remove. In this case, we can say remove recursively and interactively, which is cool because we can get a confirmation and thus make this a little safer. Unfortunately, apart from that placeholder for kind of equivalent to X in a function name, you need to end the line with a semicolon, and oddly enough, you have to escape that thing. That's unfortunate, but that's what it is. So now by running this, we get a confirmation that would you like to descend into the directory? Yes, I want to descend. Would you like to remove the empty file ABC? Yes. Would you like to remove the directory trash A? Yes. Now it says no such file directory, but I don't think that's a problem. So if I do a ls on trash or a find on trash, there is nothing in there. So that's achieved what we want. All right, with that, we finished the content of today. If you want to learn more about what we covered, you can use always the help command for grep, the help command for find and for Xarx, or there's this very cool find utils super long documentation. Actually, I need to find this one here, online version of the documentation, this one that I'm gonna copy there, and that will tell you a lot and more that you want to know about. Here is it, this one here. All right, with that we end, so see you next time.